Hi, my name is Aleo Rostata, and in this video, I will explain how the brick sort algorithm works. I will also show you how to implement this algorithm in C++. First, let's see what brick sort is. Brick sort, also known as the odd-even sorting algorithm, is similar to bubble sort, but it arranges the elements in a more structured way. In computing, an odd-even sort or odd-even transposition sort is a relatively simple sorting algorithm developed originally for use on parallel processors with local interconnections. The advantage of brick sort over bubble sort is that it improves the sorting algorithm's performance by reducing the number of swaps needed to sort the list. This is because unlike bubble sort, brick sort only compares and swap adjacent elements in the same brick, which consists of two elements located next to each other in even and odd index position. This can result in fewer swaps overall and therefore faster for some types of lists. To give you more details on how brick sort works, imagine you have a lot of toys and you want to sort them by size. This is how bubble sort works. First, you look at two toys next to each other and see which one is taller. Then swap them so that the taller one is on the right. You move on to the next pair of toys and do the same thing. You keep doing this until they are all in order. On the other hand, with brick sort, you still look at pairs of toys, but this time, you look at two pairs at a time. One pair where the first toy is taller than the second toy, and another pair where the first toy is smaller than the second. Then you swap the tallest toy from the first pair for the smallest toy from the second pair. You keep doing this over and over until all toys are in order. So the main difference between bubble sort and brick sort is how they compare and swap toys. Bubble sort only looks at one pair at a time, while brick sort looks at two pairs at a time. Let's see how brick sort works. Assuming we have given a task to sort a list of integers which are 2, 3, 7, 5, 1, 8, and 6, and 4. This list of integers is currently unsorted. Now to sort these integers, we have to determine the odd and even indexes. Take note that what we need to determine is the index and not the value of the element itself. As you can see here, our index 0 is odd, our index 1 is even, index 2 is odd, index 3 is even, and so on until our last index, which is even. And to simplify this figure, note that our odd indexes are black and even indexes are gray. Now that we know the odd and even indexes, we will sort these elements by dividing them into two phases, which is the odd and even phase. In the first run, which is the odd phase, we only care about the odd indexes. Now in our first index, this is odd, we will compare the value of this, which is 2, to the value of its immediate successor, which is 3, and swap if they are out of order. But since these two are in the right order, then we don't need to swap them. Next, we will proceed to the next odd index, which is 7, and compare it to 5. At this point, these two are out of order because 5 should be the first before 7. So we'll need to swap these two. We'll then proceed to the next odd index with the value of 1, compare it again, and swap the position if they are not in order. Again, proceed to the next odd index, whose values is 6, and compare again. Since 4 is less than 6, which means they are out of order, then we're gonna swap these two and we're done for the odd phase. In the second run, which is the even phase, we only care about the even indexes. Here, our first even index is the second one, which has a value of 3. We will compare this again to its immediate successor, whose value is 5, and swap if these two are out of order. But as you can see, these two are in the correct order, so we don't need to do anything else. Next, we'll move to the next even index. Here we have the 7 and its immediate successor has a value of 1, which is in correct order. So we'll need to swap these two. And then move again to the next even index, whose values is 8. Then swap these two again, since 4 should be the first before 8. And once again, move on to the next even index. However, as you can see here, this time our even index has no immediate successor to compare its value. So instead of going to this index, we will stop here so we can proceed to the next step. Now for the third one, we'll go back to the add phase and then continue comparing its immediate successor and swap if the two are out of order. Then proceed to the next step, which is the even phase. Then do the same comparison and swap. Now for the fifth step, we'll go back to the add phase and do the same procedure. And as you can see, after running 5 steps, we have now successfully sorted the elements. Now let's see how to implement this sorting algorithm in C++. To save you some time, I just show you this code and explain how it works. Unlike the previous video where I coded line by line, this time I have already prepared it for you. Here are our codes on the left, and on the right, we have the output and the pseudocode. Alright, notice the comments. Here is our actual function that sorts the elements. Whatever happens here is the same in our pseudocode. So, the code begins with the inclusion of the iostream library, which allows input and output operations. And the add even sort function is defined, which takes an integer array R and its size n as parameters. This function performs the add even sort algorithm on the array. Inside the add even sort function, there is a while loop that continues until the array is sorted. The loop has a boolean variable is sorted, initially set to false. The first loop inside the loop performs bubble sort on the add index elements of the array. It iterates over the array starting from index 1 and increments by 2 in each iteration. It checks if the current element is greater than the next element and if the next element exists. If the condition is true, it swaps the elements and sets a sorted variable to false. The second loop inside the while loop performs bubble sort on the even index elements of the array. It iterates over the array starting from index 0 and increments by 2 in each iteration. It follows the same swapping, and the variable is sorted update logic as the first loop. If no swapping occurs in either loop, it means the array is sorted. Any sorted variable remains to true, and the while loop terminates. In the main function, an array A is initialized with some values. These are our unsorted integers. The size of the array n is calculated using the size of operator, which determines the number of bytes occupied by the array and divided by the size of a single element. The add even sort function is called with the array A and its size as an argument to sort the elements in the array. After sorting, a for loop is used to print the sorted elements of the array. And finally, the main function returns 0, indicating successful execution of the program. And that's how we implement this sorting algorithm in C++. I hope you understand how the brick sort algorithm works, and thank you for watching this video.